right. So hello, everyone, and welcome. I'm happy to have you join us from all around the world. Whether you're waking up, taking a break at work, between classes, maybe at home relaxing, or even like tuning in on public transport, thank you for taking the time to be here. It really means a lot to both of us. My name is Carla. I'm an industrial designer. I've been using Rhino since university, and I've done pretty much everything from designing to documenting, from presentations to fabrication, everything with Rhino, designing not only products, but also designing tools to build products, fixing things, and recently, the last years, doing a lot of lighting calculations and daylight simulations. But for the last 9 years, I've been working for McNeil Europe, and since the pandemic, I've been running a small project that I now call the Educator's Lab. So I won't take much of your time before the webinar, but I want to mention this because I know that there's a lot of teachers joining today, and I want to let you know what the Educator's Lab is. The Educator's Lab is a space for educators to connect, to share, learn, ask questions, and inspire each other. So it's not only these webinars that we're starting today, but we also do a lot of workshops, usually during summer. And also we do some presentations at universities, events, user meetings, and others. I'm also trying to focus more on bringing tools and make teaching Rhino a lot easier for you. So please let us know any wishes. You can always contact me. Uploading more content for you to use on your classes, bringing new certifications to you, and also promoting the work that you do at universities and at schools. So do let us know what you're doing with students so we can share that and we can learn from each other. And a great way to connect and to stay in touch is using the forums. I created some years ago a special section that is called Rhino Teachers, where you can feel free to ask any questions to other teachers or also us, like also our development team takes a look at this. And to stay in touch, I really encourage you to go to your account, to your Rhino account, to manage your mailing list and make sure that you, by editing, select Educator if you're a teacher. I promise you, I don't send too many emails a year, but I really want to stay in touch with you. When I do, it's curated content. So said that, yeah, this is part of a bigger project where we want to provide students and educator with these 3D tools for exploring, developing, and communicating ideas and design. We have different options for that to help you with that. And maybe because you come from other software, it's the first time that you've heard about Rhino. I want to mention a few things that make us different. So our educational version is exactly the same as the commercial one. We don't have any watermarks of limitation. It doesn't expire. So even if you finish school, you can continue to use it. And for teachers, even if you stop teaching at that university, you can continue using this for also your commercial projects. So it is upgradable, and the only difference is that it has like a really big discount. If you have interest in participating in a future webinar, as we're doing today with Jose, or if you want to share some of the work that you're doing with your school or these projects, do let me know. You have my email and the other emails to stay in touch. So quick notes before we start. The session is being recorded. That's why there's no cameras, no microphones. This will appear in our McNeil Europe YouTube channel for you to go back. It will have chapters, so you can jump from one part if you want to check something specific, and some useful links. So please use the chat for questions. I'll read them to Jose at the end of the session. And if you enjoy the webinar, please share with your colleagues, with someone that might be interested and might love it too. So now it's my pleasure to introduce you, our speaker, Jose. Jose is an architect, educator, and a Ph.D. researcher. 2022, when I did the Rhino user meeting there, I had the chance to try one of these incredible cakes, beautifully crafted and even better tasting. So it's real. And from the beginning, I followed his work, celebrated his growth. I'm super I really admire you, Jose, and I'm thrilled to kick off this webinar series with you. Thank you for joining us today, and this is all yours. It's your turn. I'll stop sharing my screen so you can use yours. Thank you.
Thank you, Carla. Can you see my screen?
I do. You can go to presentation mode. Great.
Yes.
Yeah, all good.
Hello, everybody. First of all, I would like to start by thanking McNeil and Carla for the opportunity to be here today and to share my background in architecture, also as a professor and computational food designer. It's a big pleasure, and I hope that you enjoy the presentation. I have titled the presentation Computational Food Design, Teaching Rhino and Grasshopper. Introduced a bit of my background. As she mentioned, I am associate professor of architecture at the American University in Dubai. In this institution, I founded Architable in 2018. From that moment, I have been teaching the course. And currently, I am doing a Ph.D. in computational design, digital fabrication, and AI, exploring this intersection between architecture and gastronomy. And today, I will share some projects that try to bridge these two disciplines with an approach that was also channeled by the magnificent tools of Rhino 8 and Grasshopper. I will minimize. All right. I would like to start the presentation with a quote that is to me is kind of a statement, which is that I love working where design meets emotions, rituals, and experiences. And I hope that through the presentation you will get some emotions, you will see some rituals, also because the presentation also rotates about food and edible experiences. I would like to start by my early days using Rhino and Grasshopper. I had the opportunity to discover the software in 2007 while I was a student of architecture in the University of Alicante, Spain. And then as architecture student going through the master graduation thesis project, I had a big opportunity to deepen into rhinoceros and later Grasshopper. So my graduation project was a urban circus located in Manhattan in Times Square. So I took the opportunity to explore Rhino to create the design process, the diagrams. You can see here some 3D diagrams, sections, and also Grasshopper, that it was fantastic to analyze mathematical surfaces, and because I was researching about minimum surfaces, and you can see here in the project some stages for the circle representation and the artists that were inspired by the Klein surface, another one by the Enneper surface, and some others by the Moebius surface. So all this kind of geometry was feasible thanks to the tools that Grasshopper and Rhino combined together. As well, I was creating the renders, animations of the project. So as I mentioned before, a great opportunity for me to deepen into Rhino and Grasshopper that helped me out later to teach the tools at the university. This project was showcased and published in the third issue of the volume for Evolo Skyscrapers. So anyone interested in knowing more about this New York circus can approach the project through this presentation. And in my early days instructing Rhino and Grasshopper at the university, as an architect, I started instructing the students to select iconic buildings all over the world that I found very interesting pedagogically for the students to approach the analysis first of the building to understand which kind of topologies, geometries, surfaces, and curves were needed to generate this project. So I did this exercise of using iconic buildings, and these are posters and works and presentations from the same students, where we also were happy to incorporate new display modes like Arctic to create these nice architectural diagrams. And even students were exploring the animation tools of Rhino to create analysis of the processes. In this case, the design conception of the project. We are here presenting the Serpentine Pavilion of the Archangels. And as well presenting the design workflow within Rhino, like starting generative curves, creating the surfaces, doing a grid, projecting the grid on the surface, and then getting the bricks of this project. Of course, it's a project that with the implementation of Grasshopper provides more flexibility. So it was developed by the student using both Rhino and Grasshopper. Also, in this course, I like to introduce digital fabrication, how to translate the design and the geometry from Rhino to any kind of fabrication, laser cutting, or in this example for 3D printing. And the students learn the constraints of fabricating as well. Some other examples of these iconic buildings is this building, the Metropole Parasol building in Seville, Spain, Rolex Center in Switzerland, or something closer to me here in the UAE, the W Hotel for the Formula One in Abu Dhabi, where Kangaroo, in this case, was used to do the relaxation of this mesh that mimics, we can see in the floor plan, the silhouette of a Formula One car. And also, as a professor of architecture, when I was instructing the graduation projects for the bachelor degree in the 5th year here in our program, students already skilled in Rhino and Grasshopper were capable to introduce these tools into the final project. In this project called Sky Utopia, the idea was to generate a tower to replace the mobility that in the future might be sky mobility. So the building typology completely changed, and the structure can accommodate urban pods where the people can fly or get some drones or deliveries, and the mobility goes to the sky, and all these spots and living environments are perfectly adapted to the new needs of the transportation, no? And all these diagrams were generated using Rhino and Grasshopper, as well as the renders, combining these render tools with a bitrate. However, today I will be also sharing my vision of how computational design, digital fabrication, and generative AI tools commonly used in architecture in my field can inform and reshape other disciplines, such as gastronomy and food design. I would like to start this transition of chapter of the presentation and defining what is food design. And I will quote the sentence of Dr. Francesca Sampolo. She is a doctor and a researcher on food design. And in one of her recent publications, The Food Design History, she defined food design as the conscious and deliberate creative process that brings innovation to anything related to food and the act of eating across the entire food system. My beginnings crossing food design and architecture can fit inside a grain of wheat. Everything else is a consequence. One of the first projects when I was relating architecture and gastronomy or food, it was this commission from a client where I was commissioned to solve a problem. The client had this penthouse, so it was a new property, and the architect designing the project left this void with the intention to display a spiral staircase. We can notice that the location of the staircase is between the open kitchen and the living room. So this staircase became an obstacle in the communication and the view and the fluidity of the space. So the request of the client was to check the possibility to have, instead of one spiral staircase interfering the two spaces, only a single run staircase on this wall. I took the challenge, and in order to find the solution, I was doing some biomimicry studies. So I studied the wheat ear plant because this plant has the feature of maximizing in one surface the maximum number of florets through this inclination of the different florets. So for the regular thread of the steps, we get for this distance a thread of only 19 centimeters, which is comfortable for stepping at, but a bit risky or dangerous to step down. So by these inclination studies, I was able to achieve a thread of 28 centimeters, which meets regulations and also is quite comfortable. You can see that there is actually an overlap between the threads in order to achieve the feasibility of the design. And you can see here the relationship of the biomimicry. So the floret of the wheat becomes the step, and the awn of the wheat became the wires. I should mention that these wires that you can see here are only for psychological safety because they don't have any structural performance. It's only for psychological safety, since all of these steps are welded in a diagonal beam that was placed here, you can see in this 3D, next to the wall, going from the upper part of the slab to the lower part of the slab. Also taking advantage of solving the problem of the spiral staircase, I also created this down part of different material. This is steel and this is timber, and this thread is longer, so became a display and a welcoming sculpture for the guests of the users. And you can display here, you can put books, you can put bottles of wine to celebrate anything. So this becomes the welcoming piece when they enter the house. So this is the entrance door of the apartment. So you can see here the welcoming design. And also I am sharing some technical documentation during the construction process because all this documentation was as well generated using rhinoceros. 2D drawings, technical drawings, construction details, and for the workshops, etc. The first render I presented to the client was this one, and it was accepted. So then on the right, you can see the real picture after construction, and also the feeling of the space with this open kitchen without any kind of barrier. I remove also the riser of the steps. So the only thing that you can see when you are in the kitchen cooking is an open view and very thin red lines coming out of the wall, like flying. So I bring this project for two reasons. The first one is that it was my first relationship with gastronomy using the wheat as a biomimicry. And second is because the full design workflow was generated using rhinoceros. Then reflecting on how food and biomimicry nature-inspired design is helped me to solve an architectural problem, I found myself asking two questions. The first one is, how might architecture, along with the digital design and fabrication processes, inspire and inform food design and gastronomy? Then a turning point, and the answer to this question was a trip to Japan that I did in 2018. And I was very excited about visiting this project of Hiroshi Nakamura. It's in Naoshima, it's an island in Japan, and it's called the Ribbon Chapel. The concept of this chapel is bringing two helix that they cross and they meet at the top. So the metaphor or the translation is that when two people in life they cross paths and at the end they meet and they commit or they engage. And the chapel for celebrations and ceremonies is inside this structure. Also, something very interesting about this structure is that in order for this helix not to flatten, they support each other. So it's a representation of the support that you give to your partner, no, in life. So visiting the project was a fantastic experience, and these are pictures that I took also by drone. It was a very special moment to me and also to my wife, because this is the moment and the place where I proposed my wife. That's why I have the recording and the shootings. So it's a very unique building for us and very special. And she said yes. So from this experience, I got the idea of flipping and turning down the ribbon chapel and generating a memory of this moment through this 3D flying display for food. So we can see this double helix here that is accommodating up to 300 bonbons. The shape of the bonbons were generated using Lunchbox. It's a platonic icosahedron. And also the surface of the helix using as well Grasshopper and Weaverbird for subdivision in order to accommodate the different bonbons in an endless loop in a way that you can display all these bonbons. The chef can construct or build this three-dimensional plate, and the customers can deconstruct it. And this is the real fabrication, the final product that was displayed in Art Dubai. The piece is quite big. It's like 80 by 80 by 80 centimeters. However, it is 3D printed in nylon, super light. It's less than 1 kilogram, the full structure. After the trip to Japan and the augmented ribbon project inspired by the ribbon chapel, the next question, or the second question I made myself was, then how can Rhino and Grasshopper become a bridge from architecture to other disciplines, turning the teaching of computational design into an innovative and high engagement method? And this is the moment where I created and introduced the special topic course in the American University in Dubai called Architable. The inspiration was also to follow the idea of an algorithm, since I was very eager to introduce a Grasshopper. So we can understand as well a traditional recipe as an algorithm, a sequence of steps, starting from the annotations, ingredients, processes, outputs, next outputs, and final process. I would like to introduce quickly to the audience what is an algorithm and how is an algorithm related to food. Basically, any algorithm has the same structure or building blocks. Basically, inputs, key processes, and outputs. For example, if we think about making a cup of coffee, we can understand that the main process will happen in the coffee machine, but we need to feed this machine with inputs. The inputs or the data are like the coffee beans, the water, and a source of heat. After processing this data in the machine, we get the output, and the output is the coffee. And the feature of the algorithms is that the output of one algorithm can become the input of the next one. So in this case, if we continue with food, we can use this coffee to generate a coffee cake after a process or after the machine. So the final output is a coffee cake and is a link between different algorithmic phases. In Architable, I was flipping the steps to invent a new cake and recipe from scratch. So we started with the concepts. Later, we generated the grasshopper definitions, representations of the digital design, digital manufacturing, creating of the silicon molds, and finally, the recipe. So you can see that the process is it's exactly the flip or the reverse of the traditional one. This is one of the projects of the first edition. Is called Dandelion. And we can see that this is a spherical pointed shape done with kangaroo physics. It's a relaxation mesh. And then out of the three lower peaks, you can extend them to achieve or to get the legs. And also the cake is splitted, so it has a lower part and an upper part. And this is the fabrication of the two parts. The part with the cap became the positive geometry for the mold, and this lower part became the cap or the base in order to hold the upper cake. And this is the breakdown of the different steps and the recipes that were done by the students. In the first edition of Architable, I couldn't get still professional chefs on board, so all these processes were done by the same students. And this is the final presentation. We had the display with one screen with the full digital design process, the digital fabrication, and here is the real cake with the lower part sustaining the edible cap. In the second edition, because of the success of the first one, I got a lot of interest from professional chefs of the regions, pastry chefs, that they wanted to join the project. So it was a fantastic opportunity for us to collaborate with them and also for the students to be one-on-one, making their designs coming to life. So this second project is called Harmony. And it's also a very interesting project done with Rhino and Grasshopper. You can see here that for each of the cells, you can see that there is a repetitive cells and it's also sequential growth. Each of the cells, it has three parts. We can differentiate them by the colors. We have the pink, the red, and the black. However, only the pink and the red are edible. The black one is not edible. We are going to see here the process of the making, the silicon molds, and here the assembling with all the numbering. Also, nesting in Grasshopper was very helpful to arrange all the making. And here we can see that the black pyramid is not edible because it's the spoon of each of the bonbons. But the spoon has the same geometry as the edible bonbons. So these hexagonal cells can grow in any direction, and you can accommodate the other bonbons until the configuration of the final cake, where the spoon is completely integrated within the design. And this is a video of the final event of Architable, where all the students were presenting the projects along with the chefs to the audience. this event, at the end, we had also the jurors evaluating the design and the execution of the cakes. It was also a very nice educational experience for everybody. All these projects and the videos and the documentaries about the designs can be found in the YouTube channel of Architable, as well as in the Instagram account for the course. If you scan this QR code, it will take you to the Instagram page that you can follow if you are interested about learning on all these projects done by the students. And the last project of Architable that I would like to share is called Pixel, and it's a very interesting cake. The idea of this pixel cake was to have a floating cake that challenged the tradition of having the cake on the plate. So the plate is transparent and is hidden at the bottom. And also one of the features of this cake is that because it's pixelized, you can randomly display these sections, these edible sections, anywhere that the aspect of the aesthetic of the cake will be always the same. It's fantastic for catering events because you can construct and deconstruct the cake at any moment. And when you add any new slide, the final aesthetic of the cake is going to look the same. We are going to see now one video of the full process of the making and the collaboration with the chef.
Hello, my name is Aravinda Leela Ratna. I am the Executive Sous-Chef of Al Jawhar Reception and Convention Center, Sharjah. I started to work with Al Jawhar from 2009. I joined as a pastry chef, then I promoted as an Executive Sous-Chef.
Hello, my name is Narisha Mehta and I'm a future architect from American University, Dubai. The concept behind the pixel dish was inspired by the combination of three ideas: the pixel, the torus, and erosion. The torus is divided into pixels that have eroded over time. The pixels are subtracted and added in different locations on the torus surface. The dish is formed by 28 chocolate segments from 7 modular pieces. Each of these 7 modular pieces have a unique eroded surface pattern. The plate is integrated within the edible pieces, helping the dish to levitate from the ground.
The main ingredients today: bar tablet, hazelnut crunch, and the calamansi and apricot jelly. Then we add the dark chocolate and orange ganache into that, white chocolate to balance the flavors and sweetness. Then we have the unique colors of that to give more future color.
It's interesting to mention that this cake was designed by the student using only Rhino. So because of the complexity, it took her some time. And I would like now to make a live demo about how we can approach this pixel cake in Grasshopper. I just place here the geometry of the pixel cake as a reference in order for us to have a visual of the aim target design. And Let me make this a bit lower so it doesn't interfere with the presentation. And in order to start and to get this torus shape, I think we can use a Lunchbox. Also, the name of the plugin is fantastic for this exercise. So we can bring the torus surface, which is the base geometry that we are going to need for this cake. And the most important part at the beginning is to set the dimensions of the cake. In general, these cakes used to have a diameter of 30 centimeters approximately. So we can link this to the C parameter. So we get the radius, the outer radius of the cake, something like 30, 32 approximate. And then for the internal radius, that by default is 2, the section of the cake for each of the slide is something about 12 centimeters. So we can play this slider here. And we have the base surface ready as a traditional torus shape. But in this case, our aim is to create pixels around this surface. We are going to define the number of sections or divisions around the V direction and also the number of pixels for each of the sections. So in order to achieve that, we need to bring like twisted boxes on the surface. We can use the surface box component. And the input is our surface. And what we need to do is to build the domain of the surface. We need to subdivide the U and the V direction. For that, we need to divide domain. In this case, divide domain square because we need both dimensions, U count and the V count. For the domain, let's plug the surface. And now we can define properly the U count and the V count with 2 sliders. The U count is going to represent the number of slides, the one that we have around the Z axis. We can put something like 27 or 28. And the V count is going to be the number of pixels for each of the slides. That it will be also something around 25, 26. Later we can manipulate this easily, and this can be then plugged to the domain. And we can see automatically how we can play with the number of divisions, how many slides we want, and the amount of pixels per slide. All right? Very good. And the third input missing in the surface box is the height. The height is the extrusion of these pixels. As you can see, the height in the final cake is different for each pixels, so it's randomized. In order to achieve that, we are going to incorporate a random component. And for the range, we will need to construct a domain that will set the minimum offset and the maximum offset distance of these extrusions. So let's construct the domain. By default, it's going from 0 to 1. Because we want the pixels to be on the surface of the torus, we don't need to set any new value for the domain start. 0 is perfectly fine. And for the domain end, we are going to put something like 38 for the extrusion of the pixel. And here we need to know the number of pixels that we have in total in the cake. So the number of pixels total in the cake is the number of segments. In total, for these values, I have like 450. In order to get this number, I can use list length. I can plug here list length, so I can get the total number. I feed to the number, and also the seed, in order to have variations, is also a very interesting input to feed. We just put one slider with any random number. Later we can play around. And when we plug the random heights with the height input, we can see already the pixelization of all the slides. Playing with the seed, we can have variations. And then with the sliders, we can get more slides, more pixels, less pixels, etc. Once we have these wireframes or twisted box, the next step will be to morph a box within these wireframes. So let's place a center box here on the canvas. And we will use this center box to be morphed into the boxes. So we bring on canvas the box morph component. The geometry and the reference is going to be this center box. And the target is going to be the twisted box. It's taking some time, but we can see now how the boxes are being morphed into the wireframe of the previous surface box. And if we are happy with the output, we are done. The only thing we have to do is to bake this geometry, and we will get, I will group. We will get the pixel cake as we have it here. If we don't want to see the representation of the isocurves, we can hide the isocurves in Rhino. And also, once we have this design, it's pretty easy to do some modifications, some variations. Let's say, for example, we can use the box mapping. And we can play around the same. We can hide the output here. And we can input the geometry and the source, which is the box. But the target now will create a box mapping cake. If I bake, I will group the output. We have here a second variation of a pixel cake quickly developed from the initial geometry. So the flexibility of using a Grasshopper, as we know, is huge and gives us a lot of possibilities for creativity and design. So you can approach this design and practice, and also 3D printed, creating the molds and making your first pixel cake. Going back to the presentation, we also established in Architable a professional collaboration with the Chocolate Academy Dubai. So this is another project that was made for the World Cup competition, the World Chocolate Master. And for that competition, there was an initial requirement that was to integrate. We can see here, there was a motto that had to be integrated in the cake. The motto was to use hashtag TMRW, hashtag tomorrow. So the way this student integrated the letters, instead of having the physicality of the letters, what the student did, since the project was for the Chocolate Academy in Dubai, was to create a cocoa tree forest. So for this cocoa tree forest, there was like 96 trees. And then in the trunk of the tree, you can see here some bumps and silhouettes that, according to the elevation that you are looking at the cake, if you can see the cake from the right view, you will read the hashtag. And if you see the cake from the left view, you will read TMRW. So the cake was integrating the requirements of the competition, but thanks to Grasshopper, it was fully invisible or visible according or depending on the perspective viewpoint. Making this cake come true was quite challenging because these chocolate bars were 1 meter long and the thickness was only 4 millimeters. Now there is a short video where you can see a bit of the design process and the cake making.
We're here to empower the artisans to craft the future.
This event, since we were in pandemic, it was broadcasted online, the final presentation of the projects, and I had the honor to invite pastry chefs and jurors all over the world. So it was a very successful event. And this is the collection of projects developed by the students in the course Architable. As I mentioned before, you have the documentaries of the projects in the YouTube channel and also in the Instagram account if you want to know more details about the design, the making, and the collaboration with the pastry chefs. Also, I have had the pleasure to bring these projects to different symposiums and presentations. This is the GastroInnova Forum in the Canary Island in Spain in 2022, where I was presenting Architable. I brought also the physical models and I did an exhibition display there. And now I would like to introduce my personal research and that started with this teaching experience, from this teaching experience. Also, I wanted to push it a bit forward, introducing optimization of parametric designs through genetic algorithms, and to bring evolutionary computing inspired by biology. So basically working with Galapagos. For example, if we understand that this geometry initially is a design that can meet the chef requirements. However, if we think that this product is going to be mass produced, then is the right moment to start analyzing and thinking if we can optimize the geometry, and perhaps we can achieve the final design with the same aesthetic, however, using the minimum amount of ingredients. And through this analysis done in Galapagos, I was able to optimize the cake with a 25% ingredient reduction, while the design and the sizing was exactly the same. So here, what Galapagos is doing is evaluating the optimal number of slides, of course, with a threshold, a minimum and a maximum range values of 16 and 36 slides, and also checking the number of pixels per slide with the minimum of 10 and the maximum of 28. So you can see how the Galapagos is running the evaluation of all the generations and is outputting, we can see here in the lower part on the right, is outputting the fitness value of the volume. The volume is the variable to optimize, and the target is to have the minimum volume. And you can see that all the different generations are being organized on the right part of the screen and always keeping the minimum value at the top. That's why it's very easy at the end to select what is the combination that delivers the cake with the minimum volume, or on the contrary, if your target is the opposite, or your fitness value for the volume is the opposite, the maximum cake volume. In this way, you can save ingredients, and it could have an important economical impact on the production of the cake. Also, design optimization can be used not only for the cake itself, also for the packaging. And we can aim for achieving the minimum packaging. For example, in this silhouette, we can see that the geometry can fit within these two rectangles. However, the surface difference between A and B is substantial. If you have to multiply this by 1,000 of cakes, the packaging saving can be very important. So for one of the cakes that the name was curlinear, it was inspired by the Galaxy Soho building of Zaha Hadid. This cake can be displayed in the space in any 360 position, so we can rotate around the cake. And the optimization here was to find the minimum box to fit the cake in. The value that you can see running here at the top is the volume. You can see here the rotation around the three axes, X, Y, and Z. And these, the different solutions for the different generations. Towards the end of the analysis, you can see that the cake is rotating less because it's finding the optimal position to minimize the volume in order to deliver exactly what we were looking for, the minimum packaging for this cake. So we are close to the final solution. And we can see here how the volume is decreasing until achieving the minimum volume box for this cake. So it's a way to optimize not only the cake, but also the packaging. Because of this work, I started the presentation sharing with you that I am doing a PhD on computational design, intersecting these two fields, architecture and gastronomy. So I was invited to be the editor-in-chief of the University of Universities, a scientific journal. It's a scientific journal published by the University of Alicante. So as editor-in-chief of the number 4, I was proposing to have this combination of gastronomy and architecture. So the name gastrotecture, I think, represents very well the idea. These are the different publications of different architects, conversation between chefs, food designers, gastronomic scientists. And also, I incorporated in the publication of the journal a workshop that I did with the students of architecture, where they were asked to use rhinoceros and grasshopper to do food representation. They had to select one of the most popular dishes in their region, their city, or their district, so something related to their culture, and also represent the food, the display, and the history telling using Rhino and Grasshopper to create these graphics. As well, in the journal is hosting different workshops that I have developed with the collaboration of Jose La Rosa. Jose La Rosa is here, he's a biologist, and together we have gone through interesting research merging architecture, biomaterials, and computational design. I'm going to share also a project that we did together, and this is the work of the students that was incorporated into the journal. If anyone is interested in getting a copy of the journal, Gastrotecture, and learning more about this intersection of gastronomy and architecture, you can scan the QR code and get a free copy of the final journal. It's an open source journal. And these are the chapters that I am developing in my ongoing thesis, connecting these two fields. So the first chapter is about biogenerative architecture. Second is parametricism and computational food design, which is the topic of this presentation. The third one is multisensorial experiences and virtual environments. I am working also on the urban scale and the food systems, how they can affect the scale of the city and the urbanism. I am also very interested about blockchain. So there is a chapter for blockchain and NFT related to food, and also generative AI that, of course, is very relevant these days to be incorporated into design workflows and research. One project that I want to share is the one that I did with the biologist, Jose de la Rosa, where we are incorporating bio art, edible molds, digital design, digital fabrication, and generative AI. So it's a full cocktail of very different tools that we are experts in, and the project is called The Keys. So it's translating Gustav Klimt's masterpiece into a gastronomic bio-art experience through artificial intelligence and computational design. So the first thing that Jose de la Rosa and myself, we did was to write a paper that is called The Taste of Textures. And the initial idea of the paper that I will be sharing with you some notes was to understand how first the artist Gustav Klimt in 908 was addressing the painting, and also we frame from the painting the most iconic area, which is the keys. And the first exercise on AI was to translate this framing of the painting into a representation with edible molds that Jose de la Rosa had in his laboratory. So after this interpretation, we did the exercises of using 5 types of molds with very characteristic color. So we wanted to get this representation with only 5 molds. We were using the family of the Aspergillus, and we got the white mold, greenish, brownish, and black. And also for the gray bluish, we were using the Penicillium roquefort. So 5 different molds, all of them edible, in order to have an edible gastronomic experience. This is the growth of the mold after 24 hours, 48 hours, and 72 hours, where we can see that the growth was already relevant. So we stopped the growth of the mold here at this stage. And then we did a color taste correspondences analysis. The idea of this study was to understand by the color of the mold what is the flavor that we are expecting. For example, for the white color, we can expect something neutral or associated to sweetness or saltiness, depending on the culture. For the green mold, it's more related to vegetal flavors. It can be sour or tangy. For the yellow, brown color is something more umami, earthy flavor. For the black, something very intense, very bitter flower. And also, finally, for the Penicillium roqueforti, is something like a strong, pungent, or tangy taste. So it was a correlation between color and taste. Also, we did some gastrophysic studies to understand how the taste perception is built in our brain, and also the relationship with the different textures. So for each of the molds, we created this table with the optimum temperatures, humidity levels, the timing, the texture that we can associate with these molds, and also the cutlery that we can use to enjoy them. So with the use of generative AI, we created the texture associated to the mold color and the mold taste perception. So this is the texture for the white mold, something very fluid, very sweet, very dynamic. For the green mold, these are the prompts that we were feeding into the GPT, and all these prompts were informed by scientific papers on gastrophysics and biology about the molds. And this is the output, the texture for the Aspergillus lucensis, which has a very umami flavor, earthy flavor. So you can see here the texture also represents this earthy pattern. For the black mold, something very spiky, very intense. And for the blue mold, something like more branching, providing a chewy mouthfeel. The next step, after having the textures generated by generative AI, was to bring them into Rhino and Grasshopper. So this is an example for the black mold using a grid of conuses in order to generate all these spikes and some attractors with the idea to have different intensity mouthfeel while eating this mold. It's important to mention that all these tiles later were 3D printed, and they became the cutlery to host the mold growth. So the cutlery has the texture that is correlated to the mold color and the mold taste. So finally, what we are providing is an augmented experience of eating these molds. And we can see here in this picture, these are the final molds after 72 hours. So how do we relate this with the clean keys? We broke down the clean keys into a grid of rectangular cells, and then we were correlating the color of each cells with the closer color pattern of the 5 molds. So we were translating all these colors into only 5 colors, matching with our mold color, only 5. Doing that, the idea is to have in the background a canvas with the male shape. This male representation, these icons is like, I love eating fungal clean keys. And you can see here the tiles with the female shape that after tasting each of the molds, you can place these tiles back to the painting. So in this experiment that is now under fabrication, what we will be presenting is a canvas of 2.5 meters with more than 7,000 tokens. And we will invite the audience. We are planning to display this in Dubai Art Fair. So we will be inviting the audience to try and to taste each of the molds from the original tasting keys. And also after to place it into a new canvas where the saliva and the bacteria of the people will generate a new mold growth. That's why we don't know how the keys of the keys will be aesthetically is a big question mark, and this is the idea of the experiment, to bring computational design, art, biomaterials, and generative AI into this creative work. Lastly, to finalize the presentation, I would like also to share a professional collaboration I do consultancy for chefs and brands that they want to cater the identity of the company or events through an edible piece. And this is a collaboration for the Burj Al Arab Hotel here in Dubai, and with the chef, the executive pastry chef, Tom Cole. The initial commission of the chef was to have a cake representing the Burj Al Arab. So what I did as an architect was to have an inspiration of the Burj. The Burj is a building that was designed 30 years ago. So I wanted to bring into the design into today's technology with these Rhino Grasshopper tools that I am used to work with, and to propose a new design for a cake that is inspired directly by the building. No, you can see the back part of the cake that represents a seashell, since the history of navigation and pearl diving in Dubai is very prominent. Also, the front part mimics the tensile fabric facade of the building. And also you have this spine at the top that also was incorporated into the cake. So it's not a faithful representation of the building or a copy, it's an inspiration from the building. In order to develop this design, I was using SAP-D. I wasn't using Grasshopper for this project. And here you can see on the left the representation of face mode for SAP-D. You can toggle the display SAP-D. And also here in the middle, this is the smooth mode representation of the cake. The face mode is very helpful for quick editing and also to check always back forward how is the cake looking. It's always interesting to toggle between the face mode and the smooth mode. And this is also a render done in Rhino, so the full process is within Rhino 8. This is a 3D printing of the piece for an exhibition that I did in Dubai. Also, I created a painting stencil. You can see these golden ribbons were painted using a stencil. Otherwise, the timing to paint the cake can be substantial. So I provided this stencil to the chef. And the chefs went from 45 minutes painting the cake to only 5 minutes. Luckily, I got the project also featured. This is the real cake. So this is fully edible. And I got this project featured in the recently published book, The Guide of Food Design, along with some projects of Dinara Casco. And you can find this cake available in the pastry shop Les Desserts in the Burj Al Arab. They have their two versions, the dark chocolate cake and the white chocolate cake. And here on the right, we are going to see one video about the cake making. I also manufacture the silicone molds and all the casting necessary to make this cake come true. I think we are opening our appetite with these cake presentations. Last but not least, well, as an authorized Rhino trainer, I have had the opportunity to instruct different trainings in both Rhinoceros and Grasshopper, and also level 1 and level 2 for both. Two companies. This is a picture of one workshop delivered here in Dubai for architects, artists, some chefs, and interior designers. So it's always nice to see people from different backgrounds interested in learning computational tools and parametric design. And I am preparing an upcoming workshop on computational food design, specific on the topic. So if any of you in the audience are interested in taking any of these training, Rhino, Grasshopper, or the upcoming computational design workshop, feel free to scan this QR code. You can drop your name and your email, and I will keep you in the loop with the launching of the next computational design training. Thank you very much.
Thank you, Jose. It's been quite a journey to see all this, all these projects and seeing Rhino being used since the beginning by you and now being taught to so many students from different countries also. So I have some questions. First about more about the teaching part. So do you have any advice for educators who are just starting to teach Rhino or Grasshopper?
Well, one of the things that I find most inspiring for the students is when you solve the same geometry problem with different approaches. So there is no a single way to solve a geometry problem in Rhino or Grasshopper. So it's always interesting to show them how from different strategies the end result can be very similar. And then of course you have a curvature graph or surface analysis in order to go deeper and to see which one is the best option, why the continuity here or there is better, or why the surface analysis looks better, or the civil analysis. So I have been always find very helpful to teach them different methods for the same problem and then use analysis tools to prove which one is better and why.
That's great. And then, so how do you stay current with the latest updates, tools, trends, not only Rhino and Grasshopper, but also in food design? So you can maybe have two different answers for Rhino, Grasshopper, and then for food design.
Yes, for Rhino and Grasshopper, Rhino News, the Rhino magazine that was launched not very long time ago, is also bringing fantastic ideas and projects. I follow many designers, many architects on social media. I think social media is super relevant to discover new tools and the work of people. And also because of this connection with gastronomy, I feel very lucky because I have been invited in the recent years by many institutions like the Basque Culinary Center in Madrid, in San Sebastian, sorry. I am coming now in December to Madrid Culinary Campus to present these works. So I have always a food in architecture field, in gastronomy field, and it's very enrichful having this opportunity to merge both disciplines. So basically, Rhino News, Food for Rhino is also very inspiring to discover new releases, and now it's integrated with the package manager, but is as well a great opportunity to discover new releases. And social media, follow the people that you find is more creative and inspiring, and you will get inspired.
Yeah. Then there's someone, Jessica says, thanks, Jose, for this great presentation. I'm a newbie in Rhino Grasshopper and 3D printing. Do you have recommendations on which food grade filament for 3D printing and silicones for mold to use? Good question.
All right. Yes, for 3D printing can be as simple as PLA. So you create the casting of the mold. And then for silicone, of course, it has to be food graded because then it's going to be in touch with and in contact with food. And for the silicone, you have different hardness. So it depends on the complexity of the design. It's very important to choose a silicone that is very hard enough or flexible enough, thin enough, or thick enough. So it has a lot of detailing and know-how in order to make the molds work and in order to make the life of the chefs easier. That's why, for example, I was sharing the painting stencil, because before the chef was taking 45 minutes to paint one cake. And after making the stencil, which is a mask, it's only 5 minutes. So you have to be in conversation with the professional you are working with and use your skills to make their life easier and to provide a design that can cater their identity, and then it's a successful collaboration. So it's a trial error process. I am available. Reach me out if you need any tip or any recommendation about anything. I am happy to help.
Yeah, that's great. Thanks, Jose. And so, any trends shaping the future of food design? Are we going to see more AI as you've shown? Anything special that you've seen? Any crazy project?
Well, I have other projects that, because of the time limitation, I didn't bring in the presentation, but I am working also in the PhD extensively with generative AI. For example, I created a collection inspired by these edible molds, where I am designing the cutlery, the furniture, and also the interior space for these edible experiences. And I am in the phase now of creating the scripting in Grasshopper for the digital manufacturing. So I think these tools combined all together are giving superpowers to designers. And it's very important to know them, explore them in order to stay relevant. No? And Grasshopper and Rhino has been always the place and the software to incorporate all these new features. Always the developers try to develop a plugin for Rhino, for Grasshopper to test, and I am always keen to try all these different possibilities.
Thanks. So I think that's it for today. Once again, thank you, Jose. I think we've all learned a lot. We felt inspired. Oh, there's one more. Sorry. There's one that says, maybe I missed a part of the narrative, but how did you decide to end up doing eatable designs? Were you always in touch with chefs, or something just happened and you decided to take this path?
Well, as I was sharing in the presentation, the first inspiration came from the wheat plant, and years after of solving this staircase, when I went to Japan, to me it was a turning point when I saw the building, and I wanted to have a project related to the building, and I thought that bringing this into gastronomy was an excellent opportunity. So that was the beginning of everything. Because of this passion started there as a Rhino instructor in the university, I decided why not to teach these tools to students instead of designing iconic buildings as I was doing before, designing something more enjoyable that they can make through, they can try, they can share as a cake. So as I mentioned before, everything was a consequence, and it flows naturally. So it wasn't on my mind. It happened like
that. Great. So yeah, there's some more thank yous, great presentation, and yeah, I think we're all hungry now. We're a bit hungry. I think we're all going back home to just
regardless the location, I think the right
try
time
to
for
create
everybody.
something, make some molds, maybe
We have
start
something,
designing
yes.
something with Grasshopper. I'm celebrating today with cake. So I really hope you all enjoyed a new series of webinars with teachers and Rhino longtime users, experts. And I hope to see you all again in a future webinar, or also at a future event. Why not? Having Jose and maybe trying one of his cakes.
I always do that. I will bring it.
So yeah, I would love that. So thank you all. Have a great afternoon, morning, and see you next time. Goodbye.
Thank you, everybody.
Oh,
Bye-bye.
bye.